Okay, I'm actually gonna start broadcasting here. So anybody that's on, let me know if the stream is started up okay or not. So I had a request to check on some things. So let me check that real quick here. I'm watching the chat while I'm doing stuff here. So let's see. Sign in to GitHub. Okay, so I'm assuming from your username that I'm chatting with that I've got the name right here. So let me check for you real quick, and then I'll get started. Yes, I can see your commits in the repository that you were having. So, Mr. Corrales, hopefully I'm pronouncing that right. Let me know, is the live stream going okay? Can you see the audio? Good, great. Okay, I've got a few people present, it looks like. So why don't we go ahead and get started? Yeah, for anybody, online or here present today, let me know if you have questions or stuff. So let me see here. I think we're still okay. So my main goal is I'm trying out this slightly different method. I don't know if we'll stick with it or not. We'll see what the result is. Hopefully the quality is good enough, but it does have some advantages for me as well. I don't have to upload these videos or things, so it's actually will be right on YouTube if I do it this way. Although the disadvantage being that all we've got is really chat in order for me to get feedback live. So good morning. So I'm having more people join, so use the chat if you're joining on live stream. So yeah, so my main goal today is I'm going to go specifically over the assignment one, see if people have questions on that, give some hints on doing things. So let me go ahead and start up my container with the assignment one stuff in it. All right, so you can't. There's multiple ways if you've cloned your repository and you've got your container created that you can reopen the container. You can just reopen the folder. You should only have to ever clone once. So if you're not familiar with using Git, you don't really want to clone it multiple times. You'll just want one clone, one copy of your repository on your local hard drive somewhere, and you need to know where that location is. So I often use open folder, or if you use remote containers, you can just use your remote explorer and just reopen it directly from there. You can kind of save a step. So if you go here, find whichever container you want to run, click on the right arrow. I believe that's what it is. It'll open up, start the container running again, reopen it, and do stuff there. So good morning. Come on in. I started a little bit already. So I am trying to stream this. So apologies again if there's any technical difficulties or stuff. I'll fall back to just recording on the desktop if this isn't working. But it looks like the stream's okay. I got a couple of people on the stream. I got a couple of people in here locally. So as I was starting to say, I was going to we're really concentrating on assignment one. Okay, so at this point, I think most everybody does have a development environment set up. Hopefully you've gotten kind of a feel for, getting your container running. So I'm going to give you some more just today. how you do the workflow in general, but also specifically. So we've got 4 tasks in assignment 1. This is still due tomorrow. I've already had some questions. In general, the stuff is due on Friday. I often say Friday by 5 p.m. Just because I don't want people working late on Friday or working over the weekend. But I usually don't grade the stuff until I don't like to do stuff on the weekend either. So I usually don't grade it till the Monday afterwards. So you shouldn't rely on that. Try and get as much as you can get done by Friday. That is the official deadline. But especially this first assignment, there'll be no problem if you work on it Friday in the afternoon or even Saturday or Sunday for this first one. Okay, so I'm definitely going to wait until Monday to start evaluating stuff. Okay, so that's the first thing. And since somebody asked some questions on that, another thing. Maybe I'll come back to using different things on the notebook. Some people had asked about actually running the IPython notebooks in VS Code, and you can do that. I hadn't really done that much because I didn't like the way it used to work, but they've made some improvements, so there's definitely some advantages to running your notebooks in VS Code. I'll come back to that, but that is a possibility. All you have to do is install the right Jupyter extensions, and then you have to get the right kernel running. But it does look like that works fine with our development containers, just to let you know. But let me kind of come back to that maybe later on here. So I'm going to jump to using my Jupyter Lab server in a browser to talk about doing the stuff on assignment 1 here. So if you open up your container, you should get this message. This basically means that it's running Jupyter Lab, and it serves it on port 8888 on the local host. So it gets that port gets exposed, right? So it's really running in the container, but you can see that on your host system. So you can open up a browser and get that. And as we kind of showed before, I don't know if there's a better way to do this, but it generates a token which acts kind of like a password. So it generates a token every time the Jupyter Lab starts up. So you do have to find out that token to log in. So you can open up a browser yourself and just go to that port. It's a little bit annoying. I can't get to. There we go. So you can just go, open up a browser and go to localhost may or may not work on your system, so you might have to use the one. So if you know IP addresses, this is kind of a special address. It just means your local system. And then the :808 or 8888 is the port number that Jupyter Lab is running on. So you can try just going directly to that. But it'll give you like a login prompt. Well, it'll normally give you a login prompt in order to go there. So I don't know why it didn't prompt me for that. I guess I had already logged in previously here. So let me just log out here and try that again. So what would probably happen if you just went directly to that? Let me try my localhost host name on this as well. So okay, well, yeah. So I'm not certain why, but yeah, if you do get that login prompt, you will need the token, and that would be normally what you get. So as far as I know, the only way to really get that the way we've got the container set up right now is you have to open up your NoHub file. It does append to this file, so you do have to be careful. So you want to go and find the last run of this. So you have to scroll down to the bottom and find the last output of the token in the URL. So I'm getting some error messages here, but supposedly this is the one. So again, yeah, I usually just go directly to this and find that output. So I find out what my token password is and just control click on that to get it open in a browser page. So I can skip having to log in and that kind of stuff. So all right, yeah, so I think the stream is still good. So I did show a little bit of this last time. Let me know if anybody has questions, wants me to look at something particular. So I thought I would look at the tasks one by one, okay? As well as while we're doing that, we can talk a little about the typical workflow. So I do like to use the outline view, so that allows you to directly go to the different sections. So we can go directly to our task 1, or task 2 or 3 or 4, So, by the way, and maybe another goal today, I mean, I don't think I've really talked, I might have talked about this in some of my lecture videos, but I haven't really talked about using Jupyter Notebooks. So there's 2 main kinds of cells in a Jupyter Notebook. So for this assignment, you don't have to give me any written, a write-up of some results or something. But sometimes you will have to do a write-up of results. So you should always use the markdown cells if I ask you, to give an analysis. So put analysis in markdown cells, right? It might be a good idea to learn a little bit about markdown, so you can do things like get bulleted lists, numbered lists. So there's a bullet list, or if you want numbered lists, you can do number 1, number 2, and so on. And you do other stuff, highlight. You can do math markup, so you can do LaTeX math markup and other things in here. So anyway, yeah, but I mean, anytime you're writing something in English, it should always go in a markdown cell, right? And anything you're writing Python code, it should go into a code cell. Okay. And by the way, yeah, don't skip this. Go ahead and make certain you put your name and your the last 5 digits of your serial ID in your notebook, just in case I mix up files and things. Although my new workflow here, where you have to push it to GitHub, that's usually not going to be a problem. But still, it'd be a good idea to go ahead and do that. So yeah, there is a third kind of cell, but we won't use raw cells in this class. So anyway, task 1. So like I showed last time, and your notebook should run kind of cleanly from top to bottom, right? So when they start up, and by that I mean what you'll find is there's these things where we invoke some tests. So this is one of the ways that I do some auto evaluation and also give you immediate feedback on how you're doing on the assignment. So whenever you see these run unit tests, it's actually going to be taking some code or function that you were supposed to have written, usually in the assignment the assignment tasks Python file, and doing some tests on those. So these cells will run, and either the tests will be okay, so they'll pass, and this is where I left off in our last class session. So I'm actually passing the efficient. So you're actually supposed to implement a function called Fibonacci efficient for task 1, and I'm actually passing those. But you'll see, I mean, and in this first assignment, all these notebook cells are empty, so they're not really doing anything, but they are running. There's no code in them. And then we get down here, so here's an example. So later on for task 2, you have to write a function that will pass these things. And this cell is actually running, but it's failing the test, right? So it actually runs the cell. We're just getting a notification that when it tried to do some things, they didn't pass the expected output that you were supposed to get for these. Okay? And I'll show the details of some of these in a second here. Okay? But your goal is, so the very first thing that's ever done on GitHub is it does check that your notebook runs cleanly. So that means that it runs all the cells from top to bottom. We don't have something like in a cell like here that's a syntax error. So if I have something like that that's non-Python code or just some problem, if I rerun the notebook, the whole notebook, when it gets down to that point, it actually will stop and it won't run all the cells in the notebook. So if you have a notebook that doesn't run every cell cleanly that you commit and put on GitHub, you won't pass that first test and you won't get any points in the auto grader, right? So the notebook does have to run cleanly from top to bottom. So here we had syntax, and it actually stopped at that point. It didn't run the next. I can tell that in the Jupyter Lab server in the browser, because every time a cell is run, the sequence number of when it was run is put on beside the code cell. So this cell ran first, second, third, when I just reran the whole notebook all the way down to, this was the 33rd cell that was executed, but it stopped at that point. It didn't execute all the cells in the notebook. So. All right. Okay, so let's look at task 1. So So hopefully the notebook is where you'll get the description of what you want to do for the assignments. I mean, I don't know how clear or unclear they'll be. So for this first one, it's supposed to be practice on writing Python. There is some stuff on there that I expect, I mean, I kind of expect that you understand what a recursive function is as a graduate student. There is some, if you looked at the Think Python textbook, that book that I gave you as a resource to use for just learning or reviewing about Python, there is a part in there about memoization. So memoization is a technique where instead of recalculating the whole, everything you need to recalculate to get an answer for some calculation, which can be expensive, the general idea for the memoization technique is we cache sub-results or preliminary results. Okay, so that can be especially useful for a recursive algorithm or recursive calculation. So what you need to do to make an efficient version of the Fibonacci, calculating the Fibonacci sequence, is instead of recursively calling it for the previous two values, you're going to check. So if I want to calculate the 10th Fibonacci number, you need to have a dictionary, and you first check the dictionary to see if I've already cached or if I've already saved the result of what the 10th Fibonacci, the 10th number in the Fibonacci sequence is, right? So if it's in the dictionary, you just directly read it out of the dictionary and you return the result. If it's not in the dictionary, then you recursively do the same thing that we showed in the example. So you still have to, you should do it using recursion. But even if the 10th isn't in there, you might have the 9th or the 8th already cached. So you wouldn't have to do the full recursion tree to get the 8th if you have the 8th Fibonacci calculated and cached in your dictionary. So you should find, so the purpose of these time it magics is that, I'll go ahead and run it here. So for the inefficient version, you'll see that to calculate the 40th number, since there's an exponential explosion of recursion, this will take some time here. So this actually runs the function multiple times, and it reports the average of the time it took to run it here. So it'll take on average, it'll take a couple of seconds, but it runs it 10 times in order to, 'cause there can be variations in the run time. So. I can't remember how long this will take, but and I've got a relatively powerful machine, so for me, hopefully it'll only take a minute or two or less. Depending on what kind of processor you have in memory, it might take significant time here. So while that's going, let me look at this function here. Okay, so. So we showed this before. I usually doing. I'm getting the lag. Hopefully the stream is still okay. Maybe it's not though. Yeah, I do be careful. It looks like I'm still sensitive to when I have CPU. When I'm using CPU, it affects my stability. So right now it might be breaking up a little bit, unfortunately. So I might go ahead and stop that function that was run here. So, and first it would be better than this. Since it looks like that's affecting performance of my stream, so we won't be able to keep running or something, or you don't want to wait anymore. You can just stop the kernel. So this is should be a shortcut to stopping the kernel, or you can do like I think I interrupted it there. So, or you can do like a kernel. Interrupt kernel, so that's it's calling that same thing there. All right. Yeah, so I think my stream is back. So it definitely is when I have high CPU utilization, it might affect the performance of the stream. So sorry about that. So let me continue on. Hopefully it wasn't stuttering too bad. So it might not be a good idea to have the Python notebook open up in two different places, because if you edit in one place and then go back and edit in the other one, they might interfere with each other. So I probably shouldn't have this open here. I'm going to just discard whatever I might change there. So, all right. So I started saying that the other place where you will be doing stuff is in the assignment tasks, and I often just use VS Code to edit code. I mean, it has advantages. You can also edit these files in the Jupyter Lab running in a browser, but it doesn't have all the advanced editing, things to move around, go to end lines and beginnings and stuff like that. So it's a lot easier to edit if you have to edit large chunks of code in VS Code. So the inefficient version, this is just a classic a classic recursive function. So we've got base cases. The Fibonacci might not be defined this way. So it might be defined that the first two values in the sequence are both 1. You might have seen that before. We just define it that the first value in the Fibonacci sequence is 1, the second one is 2. You can actually define your base cases or your initial cases any way that you want, and it's still a Fibonacci sequence here. And then recursively to calculate, so if I want the third one, it's not one of these base cases, so we calculate recursively 3 minus 1 to get the second Fibonacci sequence. I would hit this base case, and we calculate 3 minus 2 to get the first one. And then we add those together to get the next one in the sequence, right? So hopefully everybody has run across recursion and understands the basics of how something like that works, right? So for this one, this is what I showed last time. I just copied, so this really isn't the efficient version anymore, okay? But just as a hint on this, so you do, I mean, this does pass the test because it correctly calculates, any value in the Fibonacci sequence that we ask it to, but it's doing it inefficiently still. So it does it with using recursion. It does a lot of redundant effort, so the recursion tree explodes exponentially, and it can take a long time to calculate large values in the sequence. So you should add a dictionary. So you'll need a dictionary. You'll have to know how to use dictionaries in Python. The dictionary should be global. In fact, I shouldn't have put it in the parameters list here. By the way, this is what's known as Python PyDoc or Python documentation. So when you have the 3 quotes, so basically this will hook directly into the automated help system in Python. So this documentation, in particular places, I can bring up the help, the information about the function and what it takes as input parameters and what it returns as a result, stuff like that. In later assignments, you should, if I don't give that to you, or if you write a function from scratch, you should always get in the habit of putting in Python documentation, at least a description, if not also documenting parameters and return results. So yeah, for the efficient version, you will need like an external dictionary, and I don't think I'm giving away too much here. So basically, you first check to see if it's cached in the dictionary, and if you find the dictionary, you're done. You just get the value, retrieve it from the dictionary, and that's the result. If you don't have that value in the dictionary, so you're going to have to check the key, and the key is going to be in here, which particular number in the sequence that we want to calculate. So if it's not in the dictionary, you should do something. You should do the same kind of recursion. But you need to make certain that you call the efficient version instead of the inefficient version to do this here. So what will happen for the efficient version, like if you start off, if you ask it for the 40th, it will do some recursion, but it will cache then the 1 and 2, and the recursion tree will stop. It won't do any extra calculations. Okay, so it'll happen pretty much instantaneously instead of giving a bunch of recursive calls here. So. All right. Does that? Anybody have questions on that? There was one other thing I was going to show here. So you may have to kind of look at these tests. So if a test is failing, it might be useful to know what it is the test is doing in order to figure out what's failing or not. For this first one, probably. You can understand it relatively easily, but later on, maybe even in this assignment, it might be good to know these. So all these are doing is this: you're using unit tests, Python unit tests. If you want to see those, or if you need more information about a test, those will always be in the test assignment tasks file here, right? So we've got a assignment task where you're going to put your code. You should never modify the tests, okay? So you shouldn't edit this file. I'll check to make certain that you don't make any modifications to this file. But it can be useful to look at what it's doing here. So when we test, actually we use exactly the same test for the inefficient and efficient version. So we're not using any different tests. The only difference is that we're expecting a function called Fibonacci efficient or a function called Fibonacci inefficient. But these are relatively simple to understand. So given that function that you're supposed to write in the assignment task.py, if we call it for the base cases, we're asserting that you should return 1 for the base case 1, 2 for the 2, and we check a couple of other ones. So we check the 3rd and 4th, and the 10th and the 37th in the Fibonacci sequence. So we're not doing a whole lot of extensive testing, but we're just spot checking that you get those calculations correct. Right? But that's where those are coming from in the when we run these tests. It's the test assignment tasks that you will find something called a class called test Fibonacci efficient or test Fibonacci inefficient, and then all these tests inside of that class are getting run in this unit test. Okay? And also these are the things that get run in the auto grader. All right. So I think I showed that before, but let me quickly show. Doing that again. Let's make a commit, because somebody did ask about just showing that again, I think, of how you make a commit and check it out on your GitHub account. Okay, so for this first assignment, I already did make some changes. I'll make another change. Well, I did uncomment this. I'm going to comment this back out. Since I'm having problems running these time it when I'm live streaming here. If you have those commented out, especially for the inefficient version, and if you make a commit, that could cause problems on this assignment because it will run the whole notebook, so your notebook might take a long time to run on GitHub and it might time out. So you probably should leave the inefficient version commented out, but once you get the efficient version running, it should run relatively quick, so it probably wouldn't make any problem to have that uncommented if your efficient version is working. It should run in under a second. It should, a couple hundred milliseconds if you do the memoization correctly. All right. But I'll just make another change here so I can demonstrate making a commit. And I'm just going to rerun the whole notebook just to make certain that it is rerunning cleanly everywhere here. So we're running our inefficient test at the moment. So it'll still take a little bit of time to run the 37th one. And we're running the efficient ones, although I don't have a correct implementation for Fibonacci efficient yet. So I was trying to do the 37th one again. Takes a little bit of time since it's inefficient. And there it's done, and probably everything else will just run immediately. Okay, so the notebook is done. So you do need to, it doesn't auto save for you. So be careful that you save. You can check the indication of whether it's saved or not up here on the upper left. And then I always just use VS Code to do my Git, my repository stuff here. So at this point, I think I showed this before, but I've got one file that's changed locally, which is the IPython notebook. That's the only change I made so far on this session. I'm going to go ahead and stage it as stage a commit with that file. You can see the differences on that file. So IPython notebooks, it's a lot better than it used to be. It might be a little bit tough to interpret, but it will be showing like which cells change. So for example, I should find that that cell that I added should show up here somewhere. Yeah, not easy to see, but the one with the hello world that I print out, there it is, among other stuff. So I've got a new cell in there. So I'll make a commit message. Do use good standard practices for commit messages. So I have a title with a blank line and a sentence or more of description. So an example, we added a cell to print hello world. All right. And another thing, I should maybe make an announcement of this, but please do multiple commits. Do at least one commit for each task. So once you get task 1 working, make certain you commit that work. And get it up to the repository, and have at least each task for these assignments for this class in a separate commit. I want to see you working on the assignment task by task. I don't want to just see at the end everything's done. So there's nothing and there's one commit with everything done. That doesn't give me a sense of what you were doing, how you were working on stuff, So not to mention that's also good practice. You don't want to, if you have a bunch of stuff locally, your hard drive might crash and you might lose all the work you did on task 1 and 2, and you have to recreate that, right? So, Git works as an external repository, as an external source of your code and data that you can keep it in there, right? So, let's go ahead and make a commit. So remember, there's always 3. I don't know why that's not configured. Let me configure that real quickly. My key, I showed this before. I thought I had my key in here. So the configuration, some people have this problem. I usually don't on Linux. It's usually on Windows or Mac OS. So your key needs to be copied into the container. So if you can clone, but when you get to the point running the container where you try to push your commit back, if you get an authentication error, your key might not have gotten into the container. I'm still kind of working on what the root cause of that is. I thought I had cleared that up for the stuff that I'm working here. So I'm going to redo those steps inside of my container to configure my user name, since it looks like I don't have either of those, and my user email. Oops. So again, I'm using that as my primary email on GitHub, and I'll test my connection here because I suspect that the key isn't in there again for some reason. So from a command line, you can always, oh, well, that's working. Okay. So I won't regenerate a key, but a quick workaround if you do have this problem where when you commit, you get an authentication error inside of the container is you can do the keygen step inside of the container and then copy that key. So I usually just cat or type it out. Inside of the container, you're not working in your home directory, so the key would be in /home. You're running as a user called VS Code, and then in there is where you would have your key. It might be like an ED25519 key.
So this key generation issue will be only the first time or every time?
Well, yeah. So once you generate a key, if it doesn't get copied in the container, again, the very first time, if you have a problem making a commit, you'll have to also generate the container, but you have to do that one time. Once you get it set up inside the container working, then it'll be fine. So my key is actually, what it's supposed to be doing is it will use the key agent. When it's using a key agent, it might not have the key here. It's in a different place. But that key agent doesn't always correctly communicate from your host system to your container. So if it's working, it's working. I'm not gonna generate a key. If it's not working, you can generate a key. You'll have to get it from the home vscode.ssh, and you'll have to copy that again and put it into your GitHub account. So anyway, since I can authenticate, I should be able to commit successfully here. And then you're not really done at that point. So the steps for a commit are: I stage the files I want to make a commit of. I create my commit. I've now got to commit locally, but then I have to actually sync them or push them. So like I showed before, you might get this button indicating that you've got something local you haven't pushed or synced yet, or it's good to know what the status on the bottom is for your Git. I'm on the main branch. There's nothing on my GitHub account I haven't pulled down, but there is one local commit that I could push back up here. And I don't really need to see that again about it will push and pull the stuff. So. And it's safe to have it periodically fetched. Again, this shouldn't be an issue unless you're working with other people. So if other people make a commit, you need to pull it down before you change that file. This is what it's talking about. So it'll periodically kind of for you check if it needs to pull anything down. But if nobody else is working on the repository with you, normally you shouldn't have to do this. But it doesn't hurt to allow it to periodically do that. So now I'm going to get back to my GitHub repository for this assignment. So I think I showed this before, but since I didn't have it already open here, one way you can get back to it is if you go to your GitHub account. You won't find it in your repository since my organization for this class owns it. So if you go to your organizations, you should be a member of the 574 Spring 2025 organization, and you will only have access to, and you will only see your assignment repositories in here. So I want to see this one here.
Is Git pull required if I'm the only person who
It should never be necessary. If nobody else ever pushes a commit there, you won't have to pull it down. Or if you have a lap, it might be necessary. So if you're doing work on more than one machine, so if you have a laptop and a desktop system, if you make a push from one system, then you want to work on it, then on your laptop, you would have to pull it down before you continue working on there. So yes. So anyway, that commit that I made should have ended up in the pull. You should always have what's known as a pull request. It's always good when you make a commit to check that. So this is the one that I just did now, the example commit for task 1, where we added in the print hello. It's actually still running, so and like I was mentioning there before, there might be a lot of output here, and for let me make this a little bit bigger. It's a little bit tough to see for my people that are here, for me to see. So the very first thing it'll always do is check if your notebook runs cleanly. So if that fails, actually I guess your test might still run, but that's part of the test. It just makes certain all the cells run in the notebook that you submitted, and then it's running those same ones. So whatever you're getting locally, you should be getting the same results here. So it's running the unit test for the inefficient and for the efficient, and then it's going to run the task 2 and all the rest of the tests. Those aren't passing yet. And so far we're getting 3 out of 7 or 30 out of 70 points because we're passing. The whole notebook is running, and the 2 little unit tests for task 1 are running. So. All right, haven't been getting any chat messages from my live stream people. Let me know. I'll have to look at the live stream after the fact, see how the quality of the recording is. But if you guys have questions too, I am monitoring the YouTube live stream chat. So, all right. But yeah, as far as I can tell for the stream, except for that time when I was running the time it looked like the stream quality went down. It looks like it's been okay mostly for this session here. So. Okay, I can remove that. So let's talk about the other tasks. Let's see if anybody has any questions about those. So there are 3 other tasks. Getting a little bit of a slowdown now for some reason. Okay, so again, I kind of like the outline here. So let's jump over to task 2. I usually turn off these line numberings, the subheading numbers. So on task 2, it's supposed to be practice on NumPy. So actually, you need to put some of your work goes in the notebook. So where described, you should go ahead and just as an example, you have to first create an array called X and an array called Y. They should have exactly these contents. Okay. So it's fine to hard code them with these values. Although you might want to practice using you can also do this with like a range function. So you can use the NumPy array range function to get a range of values, a linear range of values, starting at this begin value, ending at this end value. That would be probably a better one, so you can practice using range. A caveat about this one, I think I make it clear here, but this is not a vector. This is not a one-dimensional array. This is a two-dimensional array that has 1 row and 5 columns. So the shape has to be a 1 by 5 here to be correct on this first one. And likewise, this is this is a 4 row by 1 column. So this is shaped 4 by 1. The shape when you output for an array is for two-dimensional, we always do it conventionally by number of rows and then number of columns. So I would call this a 4 by 1, and I'd call this a 1 by 5 here. All right. So it gets more complex after that. This is just a little bit of practice, but what we're working up to is we need to end up with arrays, these 3 particular arrays. What's the last one here? So before we do the tests here, the final function that I asked to write should return what the MT and Z here, right? So your final Z should end up looking like the one right here. Before we do this, those are what it should look like, and I think that's what it should be being returned from this function that you write. So M is just an array of booleans. It should be exactly of this shape. So we've got 4 rows and 5 columns. It should be false for the first and last column and true for all the stuff in the middle. Do use masking, okay, to do all this stuff here. So basically, the idea is you want to create this Boolean array by doing a Boolean expression on the Z array here. So any place where the absolute value of Z is greater than 2, so any place where the number here is greater than 2 should be false, right? So you can see that the first and last column are greater than 2. Anything where it's less than or equal to 2 should be true when you apply this mask here, right? And you should be able to do that if you read the lecture notebooks on more fancy kind of indexing and more advanced this kind of Boolean indexing. The simplest thing is just to do a Boolean expression against the Z array to calculate or update the M array. Right? And the same goes for the T and the Z. So the T, so here we're going to be using this later on. We're going to be updating T. So T should have been initialized to have all zeros in like a previous step here. The same shape as Z, 4 rows by 5 columns, but with all zeros. So this step here should be updating T, but any place, so you should use Boolean indexing here. So using this mask, any place that the mask is true, you're going to set the value of 1. Any place is false, you shouldn't modify any place where the thing is false. And you can do that using a Boolean mask. Okay. So when you do the next task after this, though, you're going to be updating T, but for the second iteration, any place where the mask ended up being true, you're going to set it to 2, right? So this is basically just being updated with the time index, this T array that I call the timestamps. Right? Some people get confused because I called it timestamps, but it's really the time index. So it's not like an actual time, date time here. It's just every place where M ended up being true, every place where the absolute value was still less than 2 at time index 1, we should set to 1. And every place where the absolute value was still less than 2 at time 2, we would set those at 2. And we're going to be iterating like that for the third task here. All right. And then also, this should be relatively simple. You should be able to use an expression, but you do need to use Boolean masking again. So for Z, you're going to update Z. Again, only the places where it's true. So you shouldn't be updating any of the first and last column on this one. So the first and last column after we update Z here, this is the absolute value of Z. So Z should have been this here. But hopefully this looks the same. So that first and last column are still the same because those were false. So only these middle ones got updated. So basically to update these middle ones, you have to use a Boolean mask, but at those locations you want to square what's currently in Z, add the C to it, and update those results back into Z. Okay? And this should be just a single expression, or you can do it in a single expression. All right. Okay, and then if it's not clear, so the task 2, I just ask you to the easiest thing to do would be if you get that all working and you get exactly the same output for your M, T, and Z, you can just copy and paste all that code into the function for testing. All right. So some of these steps may not be necessary to calculate the finals M, T, and Z, but that would be the easiest thing to do. Right. So what we're asking for, if we go back to the VS Code and we look at our assignment tasks, there's a function called task2 numpy operations. Right now, if it's not clear, it's just returning some stuff. So it creates some 2x2 arrays of all zeros and just returns those, so that the test can be run. They just won't pass because it's not returning the expected results here. So you really should delete this code, but then put in your code to calculate the preliminary results and then calculate the final M, T, and Z, and then you still want to have a return statement that returns the expected values for M, T, and Z. All right. And again, if you look at the tests of the task 2, I mean, they're very simple. So we expect that M should be of shape 4-5 and look like that. T should be of shape 4x5 and look like that, and Z should be shape 4x5 and should look like that with exactly those complex values in it. Right. So, the way we're doing it, so notice, I mean, just a little bit about how these unit tests work. There's one function that's called before each one of these tests happen. All we do is call your function, which should be returning M, T, and Z. So now we've got M, T, and Z as member variables of our class here. And then each one of these tests test individually different properties of those arrays that you're getting exactly what we're expecting. All right, and stop me or feel free to ask some questions. because I've got maybe about 10 more minutes. The one of the big reasons, so task 2 is about practicing NumPy, so some motivation that you learn NumPy, but especially learn like doing Boolean indexing and fancy indexing, and some of those other things that you can do with NumPy, as well as just doing vectorized operations. Part 3 is going to be reusing those concepts, but we're going to implement a function that kind of repeatedly does these last 3 tasks, where we update m, t, and z based on which values, absolute values of z, are greater than or less than 2. All right? So hopefully that's not clear. So you do have to write a function called iterate Julia set. We'll see whether people think this is clear or not, but I give relatively detailed kind of the algorithm. So you've got 2 steps where you initialize some stuff. You do need to make a copy of z, so z needs to be passed in as a parameter. So you can see how this function is called here. So we pass in a z that we initialize for you here, and a c, and also a third parameter, number of iterations. All right, but you need to make a copy of this z. So again, if you look at the tests for the iterate Julia set, we will call your implementation of iterate Julia set. It needs to return the t, but also, if you don't make a copy of the z, we will detect that after the fact, right? So because if you're modifying z inside of the function, it will actually, you'll see those changes you make to z here. So we test that z is still the same before and after when you call it. So this is, I wanted to mention this, or we test this explicitly because this is something to know. So usually when you pass in values to Python, they're passed by, when you pass parameters, they're passed by value, which means a copy of it is made. So if you modify that parameter inside of a function, it won't make it, when you return from it, it won't affect, if you were passing in a parameter. But arrays are done differently, and this is for efficiency reasons. So, arrays could have thousands or even millions of values. So if you made a copy of all that every time you passed a NumPy array into a function, it would hurt performance, right? And NumPy is all about doing matrix operations with good performance, fast performance, right? So for that reason, by default, arrays are never copied when you pass them in as a parameter. They are a reference to the array is passed in. So if you modify that array inside of a function, those modifications will be seen when you return from it, which is not always what you want to happen. All right, so you just have to be aware of that. The normal thing is to pass stuff by value, make copies of it, but NumPy arrays work differently. All right. Sorry, lost the place here. So yeah, the first 2 steps are initializing. So you have to make a copy of z. Don't skip that. You have to initialize cm and t. This will be similar to what you did on the step, although the shape won't be 4x5 anymore. So whatever the shape of z is, you have to initialize cm and t with the same shape, so that c is an array of the complex numbers. So the complex numbers will be passed in as a parameter. That's the second parameter. So all the values in the initialized z of c is the same. So uppercase c is the same shape as z, but with this value initialized for all those. And then t is initialized the same shape as z, but all zeros. M is the same shape as z, but initially everything is based on what the initial z given. So the same check, whether the absolute value is above or below 2, will be whether the values are true or false in the mask. And then you have to have a loop here. So the loop should execute exactly the number of iteration times, so 0 up to the number of iterations. Right? And then you're going to be doing those steps like we did the last one. So you update Z, and then based on the new values in Z, you'll update the mask, depending on whether the absolute value is less than or greater than 2. And then once you have that mask, you'll update the timestamps T. So that anything that's still true should have its timestamp. And again, the timestamp is really the iteration number, the loop number. Right, so anything that hasn't fallen out of this iteration, so anything that's still true gets its time index updated in the matrix called T here. At the end, you just return T. Right? So again, I mean, all that work pretty much happens in the assignment tasks, right? And again, there's a stub here, so you do need to return T, but instead of initializing to zeros, you have to do what was described there, and then after you iterate some number of times, you return what's in T, right? That's what's actually being plotted here, right? So anything that is really bright yellow never fell out. So all 255 iterations, the absolute value never got above 2, right? And everything was black, they immediately, the absolute value was already less than 2 when we did that calculation on Z, right? So I mean, I don't know if I had a link on that. If you're interested, this is an example of a fractal. I can't remember where this example came from. But yeah, I guess I don't have a link on here, but you can look in Wikipedia for what a Julia set is. But you don't really have to understand what's happening here. We're just doing this calculation, which calculates this fractal pattern here. So. Yeah, if you do it right, when you run this cell here, you should see exactly the same figure. Right? So it's another check for you. So not only passing the tests, but the figure that gets plotted will look exactly like this fractal here. Right. Okay, and then finally, there are a couple there's 2 or 3 unit tests that happen on pandas. So the last one is practice with pandas. We'll be using pandas in this class pandas is a, if you haven't gone through the lecture notebooks or watched the video, it's a library that's mainly meant for data analytics. So it's a way of reading in either from a database or a file. We'll mostly just use small files of data. So it reads it into, normally we'll use them as like a table structure. So where each row is a sample and each column is a different feature of things to do, right? So Pandas is very useful for doing data cleaning, doing initial data exploration and stuff like that. So we'll get more, we'll do some more stuff with that next week, right? But you do need to load the data frame. Always use relative paths when you load data frames. So there is a file in this assignment that's used for task 4. It's in the data subdirectory, okay? So your notebook runs in the notebook subdirectory. So to open this file, so when you run the thing to load the CSV file here, like you're asked to do, so you need to delete this and actually call like a load CSV or something like that to load this file. But you should use this relative path name. So if you go up one directory and then go into the data directory, that's where the data is that's done for this fourth task. All right. So it's just a small one. So we've got 15 samples of sales data, and these are the features, like an account number, the name of the company on the account, and some other stuff. Right. So you do need to do these cells that are asked for in here, and then we ask you to, I mean, these aren't the way that I would normally write a function, so these are just mostly for testing and illustration purposes. So you do have to write one function that does some panda. It's a requirement to use pandas for this inside of your function, and also out here when you're doing these things like displaying the lines and displaying the numerical attributes of the data frame. So yeah, I mean, when you calculate the sum of the sales in January and the minimum of the sales in February, these are actually really simple. Most people shouldn't have any problem figuring out how to do these, but you just return those three values, right? So we return whatever the sum, the minimum, and the average are of those three separate months as a tuple, right? And we pass in the data frame. So the data frame comes in as input called df, and you use pandas operations to calculate those and just return those. Same for this. This one here, the operations you're supposed to do should modify. So you need to actually create a new data frame that, so this is called mutating, where you change the name of the particular column, to what was asked for, so it's renamed, I can't remember, I think just zip code instead of what the name was originally given as, and then calculate, do some stuff to find if there's any missing values in the states and the zip codes. So again, if we look this up, so we're asking to rename this to the more common zip code instead of postal code in the mutated data frame, and then you have to check, so there is some missing data like on the state and the zip code, so count those up. But again, use NumPy operations to find those. So.